So I'm back. The set should definitely look a lot different now. I got all the boards painted. I have some mountains in the background. We're not going to really talk about those today. We're going to talk about electrical signal track. We've been using the pressure switches for signal, the feedback for the last few circuits, for the stop-start circuits. Today we're going to use electrical signal track and how to make it and how it works. Before we start, I'd like to ask if anybody could leave a comment, good or bad, just to give me a little bit of feedback would be great. So I have basically one train set up in the middle. We're not going to be using that one at all today. We have the other train set up. We're going to be using that one. We do have a signal track over there behind that little molehill or mountain, whatever you want to call it. We'll see that turn on here in a little bit. So what we're basically doing is we're taking our track here and we're going to turn this into a signal track. To do that, we notice that we have this little insulator material that keeps the center track electrically separated from these two outer rails. Normally this outer rail and this outer rail are tied together through this base plate so they have the same electrical polarity or same electrical value. So what we're going to have to do to make signal track is to remove this rail. So we have to peel one of these back in 3 places and insulate it. I tried using electrical tape to do that, and it really didn't work out well. I cut it trying to fold it up. I cut some little piece of cardboard and tried to get that in there, and that didn't work as well. So I think I might maybe try some vinyl material next. Now you can buy this track pre-made, so you don't have to worry if you don't want to try it or what you do doesn't work out. Also, when we put one of these into the circuit, we have to take this metal pin out, replace it with a fiber pin, and the same thing at this end of the track has to be replaced with a fiber pin. So we'll have to pull one out of the track that's coming into it and replace that. What we're trying to do in this circuit, I drew up, we have our neutral side, let's see if over here, side of the transformer. We have our hot side of the transformer that comes in, and then we have the third rail that we have isolated, which is now hooked to basically nothing. It's just floating out in space. I have the train, the negative or neutral and the positive going to the train as it sits in the track. The wheels on the train are made of metal. The axle's made of metal. And what's going to happen is the train rolls across this track. We have our positive out here going to our load. We have a light or a solenoid or whatever we want to run off this. Then we go back to this wire. And it comes back to this isolated track. When the wheels across the train come up and go across, they're going to create a path for electricity to come back, feed across, and create the neutral circuit. So I have a section of isolated track here. I have this little light on there to indicate when this is made. I have the transformer powered up already. So when we roll this car across here, we should see that light turn on. I also have this crossing gate wired in too. So once our train goes across, moves to the next section of the dead track, off of it, the light turns off and the crossing guard turns off. That's how we get our signal fed back to the from the train. Now I'm going to go ahead and remove this car. I'm going to fire up that outside train. If you watch right by that little green building, as I bring this online, the little yellow light will come on over there because I have another track over there. That signal track. So I have this wired up. I'm going to have to power down my transformer. I have this set up similar like I did before. I have the main power on off switch, which I'll turn back on. And I have the 3-way switch here, so I can select the outside track or the inside track. We're not using the inside track. So I'm going to go ahead and power up my train, and we'll see the little yellow LED come on. And as we bring our train around, we'll see this red LED come on. You also can watch, we'll go around again one more time and we can see that little yellow light come on again. And since we got this crossing guard wired into the train, we'll see that turn on. Now watch as this goes by with this LED. And notice that it starts flickering at the end. And that's happening basically because the engine of the train is the heaviest, and then the cars start getting lighter. The coal car would be the next heaviest, and we always want to run our trains as much as possible with the lightest cars in the rear to help it from derailing around corners. And that's the issue we have. We have, these trains bouncing around. They're light, so they're not conducting very good electricity. That's why we get the flutter, which is going to lead into a problem. Also, with the track being so short, the signal's going to only be on for that little bit. So we're going to see our crossing guard turning on and off and bouncing up and down. Now, if we put a longer section of signal track in, like another signal section, obviously it's going to stay on longer. The second issue with this type of track, I'm going to bring the train around again, which I need to bring the power up. And as we can watch, I'll move over to the crossing guard. If I stop the train in this section of the first, now it's not going to do it for me. Let me stop, reset this, and get it back where it's working. Okay, I got this working again. I don't know what happened. Obviously, these trains are kind of temperamental if you ever work with one. I don't have any of the track secured down. I don't have any clips put in, so this is walking around a little bit. Like I was saying, if I power this up, running it again, I will have power to this track. I should have put a light in there. And our track will come on again. If I power the train off, though, and stop in that position, since this LED and the crossing guard are powered off the track itself, those both won't work anymore if you stop the train. So that's a negative using this type of circuit. Now we can fix that. We'll talk about that down the road. I'm going to go ahead and move this off the track for right now. Okay, I got that out of the way. But one of the positives of doing this is the fact that we have a pretty smooth transition through there. We can nail our track or screw it down. I never recommend screwing track down really tight. The other thing we could do if we're putting a nice layout out and we don't want this connector to be there or be able to see this thing, we could always drill holes through the plywood if we're working off something like that, bring the wires straight up and either hook them to the rail and hook them to the center rail and get that signal without ever knowing it's really there if you're that critical into a layout. So that's a positive plus of this. But again, the negative is the fact that if you stop the train on the track, all the power goes out. Also, whatever running for accessories has to be ran off the AC voltage, no matter what you set it to. If the train's running faster because you're giving more power, your accessory is going to light up harder. If you're running really slow, the accessory might not even make it all the way down. This one, I'm missing the spring on it, so it's definitely not going to come back up, but you might have a fluttering of this going up and down at a lower speed. There is a way to fix that. We'll talk about that later. But that's just how this type of circuit works, what's going on. Another negative thing is when you're running this type of circuit using the track signal, every time all your current is going through the wheels of the train and through the locomotive when it's used as a switch like what we're doing. And if we have several accessories hooked off that, if we had our crossing guard and then we hook another crossing guard on the other side the other way, if we were turning a light on at the same time or turning a bunch of accessories on at the same time, all that current's coming back across this train. Or if we were trying to trigger another train to come on, every bit of that power is coming across this train. So if we're going to do that, I would definitely recommend triggering a relay and bringing the power across those contacts versus coming across the wheels or on the train. Any questions, any comments, leave a like, leave a dislike, well, don't leave a dislike, please, but leave a comment, positive, negative, that would really help out me. I think the next one we're going to go into back to using the metal contactor and talk about the pluses and negatives of that, just to get an idea when you set up your track what you want to do. Alrighty, thank you.